Welcome to the beginner's edition of GraphQL Berlin. This edition of the meetup is dedicated to the up-and-coming adepts of the GraphQL art. So while this meetup has started in Berlin, the transition into this online format has allowed us to bring together the global GraphQL community. I'm your host, Daniel, and today we have two speakers and a special guest is going to drop in. Our first speaker is going to be Vignesh T.V, whose talk title is GraphQL from A to Z, followed by the special guest, and finally, Stephan Schneider, who's here to talk about ramp up your GraphQL learning experience with the data that you already have. This meetup is organized by Prisma, and in case you're not familiar with Prisma, Prisma is the easiest way to work with databases in Node.js and TypeScript. So today, we'll be running a quiz throughout the event, and the quiz will be split into two parts. In order to participate, you can go to slido.com/GraphQL, and we will drop the link in the chat so that you can find that quickly. And the first place of the quiz will win a Learning GraphQL book by O'Reilly, Prisma swag and Contentful swag, and then the second and the third places will also win some of the Prisma swag and the Contentful swag that you see on the screen. So to get us started, we already have a little poll here, and we'd love to hear where you're joining us from. I'm joining from Berlin. Vignesh, I believe, is joining us from India. And our other speaker, Stephan, and our special guest, Dominik, I believe, are also joining from Germany. So we have a guest from Kenya. That's lovely to hear. We're already covering 2 continents. We have Bangkok, Thailand. So that's 3 continents right there. Let's see. London. So as you all join in, be sure to keep your Slido window open so that you can participate in the quiz, because the quiz will be running throughout the event. We also have the US, so we have now America too. So it's really lovely to see how the global GraphQL community is coming together. And I think we can already introduce Vignesh. So I'd like to introduce Vignesh before he sort of comes on stage. And in case you don't know, Vignesh is the founder of Time Campus, a bootstrap startup building a time management platform for users and businesses. Before becoming a solopreneur, he led a research and development team of 25 at Ramco Systems and also served there as a consultant for some time. He spends his free time blogging on Medium about a range of topics from time management and productivity to the open source ecosystem. So GraphQL, Kubernetes, web components, architecture, and so on. So now without any further delay, Vignesh, how's it going? It's nice to have you here today.
Hey, Daniel, it's a good going actually. Apart from the COVID situation we have out here, so, everything is great. So how are you?
I'm doing well. It's a little bit cold here in Berlin, but I'm really excited about some of the content that you have ready for us today.
Yeah, I'm excited as well. So, actually already I'm excited after seeing all the people joining from, throughout the world. So, yeah, hi everyone.
Okay, so without any further delay, I give you the stage.
Sure. So, let me so that I can quickly get started with the session. So, yeah. So I hope you are able to see my screen, if I'm right. Okay. Yeah. So today's talk is going to be all about GraphQL, right? So as Daniel mentioned, so we are going to talk about GraphQL A to Z. So actually, before starting off this session, I had a discussion with the Prisma team on how we should title this talk. We started off with the title GraphQL A to Z. Then I titled it Diving Deep into GraphQL. But then finally I realized the fact is that it is not possible to cover A to Z or go deep into GraphQL in the 30 minutes I have, 30 to 45 minutes I have. So it's not possible to go deep, but what I will do in this session is probably take you through or walk you through a crash course of what GraphQL looks like, the entire ecosystem of tools out there. And once you are introduced to everything, probably you can read up more on that or read the blog series which I wrote. So let's get started with a quick introduction about myself. So myself, Vignesh. So as Daniel introduced, to all of you, I'm a solopreneur working on Time Campus, which is a time management platform for users and businesses. And I led an R&D team before. So my background is full stack developer, and I used to work on DevOps as well, and quite a bit of machine learning. So I like to call myself a generalist. And this is what is Time Campus all about. So it's a time management platform. It's a bootstrap startup where we are launching soon in 2 months. So we have a lot to talk about. So without any of this introduction, so let's jump into GraphQL straight away. And for a context, so this is what the stack looks like. This is what we use at Time Campus. So if you see all of it is bleeding edge, I would call it a cloud native stack. And you see GraphQL right out here. So so it's basically a stack which is meant for solving the next generation problems in the most interesting way. So I will actually give you a context about all of this at the end of the session, but let's jump into GraphQL for now. So this series on GraphQL is what I published on Medium a month back, and it's probably about 66 minutes long. So, and we are going to probably shrink that into 30 to 45 minutes and probably give it to you in this session. So that's what we are going to do. And let's jump right into it. So what is GraphQL? And all this content which you see here in this slide is taken from GraphQL.js. So I have done nothing here. So I just put together all the amazing content out here. So you can basically see what GraphQL is in one slide. So GraphQL is a query language for APIs. So you have REST APIs, which is one way in which you can query data, do operations on data. So you can create records, update records. So you call it CRUD, right? So GraphQL is like a complement to REST, or rather I should say substitute to REST, not complement. So it basically, takes over from REST on all the challenges we had with REST. So from having to define every single endpoint for each and every operation we would want to do. For instance, for getting the user information, you would probably define an API. For getting for creating a post, you would make an API. For getting the list of posts, you would make an API. So the list went on and on and on, and it became difficult to manage. And it's not just that problem. We had a ton of other problems because you had to make a ton of HTTP calls just to get information. So that's where GraphQL came into picture. And the more important part about GraphQL is it comes, as I said, it takes over from the challenges with REST API. So let's quickly get into it. Probably you can understand more as we go on. So first step is ask exactly what you need. So if you want a user name or user information, or if you want to get a list of all your friends, that's exactly what you ask for, and that's exactly what you get. So if you see here, you just ask for a hero name, and what you get is a hero name. And the second part is, you can get as many resources as possible in one request. So it's not necessary to make a single request for getting the user information, and another for posts, another for comments. So you can rather, for instance, in this case, I can ask a hero name, I can ask his friends, and I can ask their names and whatever, all the information, all the related information I want in a single query or mutation. So that's the power of GraphQL, that you reduce the n number of HTTP requests you make into one. So that's an amazing power. And the next important part is the type system itself. So GraphQL has a powerful type system which is also self-documenting. For instance, in case of REST API, I have to define a Swagger documentation to complement all the APIs which I have. So I have to define what my payload is going to look like, what my endpoints is going to look like, what are the types, and I have to define all the things, right? And it's not also enforcing, and then you have to go to the code and add validations to it. So you had to do a ton of things to get it strictly type compliant. And sometimes you might end up defining a Swagger documentation for a field to be string, and you might end up using the same field as integer. So it doesn't enforce a type. Swagger is meant for documenting the type. So, but rather, in case of GraphQL, we have a powerful type system which helps you not just document but also enforce types. So the validation won't allow you to query or do mutations if the type doesn't match. And if you see here, it's not just a type of a single element. So you have nested elements out here, and you have a powerful type system, and you navigate through. So there are basic types which GraphQL supports. One would be ID type, it's a special type to hold IDs. Another one would be string. Another one would be Boolean. Another one would be float, and then integer. So these are all the types which GraphQL supports in out of the box. But you can also add types to it. You can define your own scalar. You can define your own date time type. So you can define your own geo coordinate. So all of that power is left to you. So GraphQL tends to be minimalistic framework for all the people who are out there. So yeah, that's what GraphQL is all about. So as the website states, describe your data, ask for what you want, and get predictable results. So yeah, that's pretty much GraphQL. And let's dig deeper into this scenario. So in case of REST API, you will basically create multiple versions for multiple sets of data you're going to query, going to mutate. So each and everything will have its own versioning. So, but in case of GraphQL, what you have is a single endpoint. Slash GraphQL, and that is the only endpoint you use for doing all the operations. And if you want to add a new field, remove field, you just operate on the same field. You mark it as deprecated. You use directives to mark it as deprecated, and you just proceed. So I don't want to make this a GraphQL tutorial, so I will just stop here. So what you can do is you can also generate code, like you can generate TypeScript code from GraphQL schema. So because GraphQL is strongly typed, you can do a lot of powerful things with it. Like your editor can support IntelliSense, and you can generate, as I told you, the TypeScript types out of GraphQL types. So you can do almost all of it. And not just this, there is a powerful feature called introspection in GraphQL, where you can ask GraphQL about the schema, and it will return back all the response regarding the schema itself. So, and talking about powerful developer tools, so this is GraphQL, and this is how it looks like. I'll just quickly skip through this video so that you probably get the picture. So you can basically ask for the title of all the films you have, the opening crawl, and you can just ask for the fields what you want, and you will get the response. So that's what GraphQL looks like. So you ask for the title and opening crawl, and you get exactly that. So, and if you see here, you just did a control click, and you can drill through the documentation. Okay, I'm going into the film type, and I'm going into all the basic types which it has. So that's the power of GraphQL. So it's not about just the schema itself. So GraphQL has a complete ecosystem around it. So there are a lot of developer tools out there which builds on top of GraphQL using the powerful features like introspection. You have other things like subscriptions. You have the powerful type system. So GraphQL does come with a lot of perks. But before we dig into more of GraphQL and the ecosystem, so let's quickly look at a history of how GraphQL has evolved over time. So it was initially, created at Facebook. So this page was open sourced by around 2015 with a just rough implementation written in JavaScript, which is GraphQL.js today. After that, people really identified that this would be the next birth of APIs. And that's due to a lot of factors. One more important thing about GraphQL is that it is protocol independent. What I mean by that is, so you don't have to worry about whether you use HTTP, RPC, or WebSockets or anything for that matter. So you can directly do all your operations using the protocol you already use. So that's all the power which GraphQL comes with. And recently, Facebook moved GraphQL to the GraphQL Foundation. I mean, they created a GraphQL Foundation, and they pushed GraphQL project there. And now that is where even other projects like data loader and other projects live. And here we are today. And if you just look at the GraphQL system, the size of it, it is not possible to talk about all of it in this 30 to 45 minutes I have. But let's do some justice to the time we have and the tools and the ecosystem as a whole. So I don't want to go so deep into REST versus GraphQL, but let's quickly jump into it. So before this was the case, so you have backend for front end. So if you are using REST, this is how you would do backend for front end. For instance, let's say that you have a mobile, you have a website, you have another client, you have what people ended up doing is, by the way, this is the architecture of Spotify, if I'm not wrong. So Spotify, what they did was they created a separate set of APIs for each and every client they are using. The reason was that they don't want to transmit all the information over the wire. So they didn't want to reuse the existing APIs because existing APIs tended to give a lot more information than what is actually needed. So what they rather did was they built out separate APIs for each and every client out there. And that's how they worked around, because REST didn't have any other solution because that's all they have, right? Completely. And if you're using a mobile, you can just query for the data you need. If you're using a desktop, you can just query for the data you need. So that's how the tradition has changed from REST to GraphQL. So if you see here left and right, so for getting the same information, you need to do 3 requests in REST, and you can just do it all with 1 request in GraphQL. So you can minimize the number of requests you send over the wire, and you can directly get what you need. But now that I have talked about all of this, is GraphQL good for everything? So we do have REST as well, right? Which is a powerful competitor for GraphQL, especially given its simplicity. So sorry if I'm going too fast, but that's because we have a lot to cover. You might actually see me going through GraphQL A to Z. So yeah. So is GraphQL good for everything? And I would say no. The reason is because it depends on your use case and complexity. So let's say that you have a simple use case where all you want to do is get the latest let's say weather. So in such cases, if that's the single endpoint you have, so why bother putting up a boilerplate with GraphQL? Why add more complexity to the stack? So you can just define one endpoint, one REST endpoint to basically give you the latest weather for the respective location. So GraphQL might tend to be overcomplicated and will also have some more challenges, which I will be talking about as well. GraphQL does require a lot of boilerplate on the server side to get it set up properly, especially if you are using a federated or distributed architecture, distributed data graph. So by distributed data graph, what I mean is you split your schema into multiple microservices. So GraphQL comes up with all these problems, but yes, there are solutions available to all these problems, which I have outlined in my blog post. I won't go so deep into all of these, but there is n plus 1 problems where you make n number of requests plus 1 for getting a single, for making a single GraphQL request. So for instance, let's say that you want to get you want to get your friends and the list of posts each one of them made. So you will end up making n calls for your friends, n plus 1 calls, and then you have to again make a call to get their post and then that information. So it comes up with an n plus 1 problem. Then it doesn't have caching in place because you typically use a single endpoint, right? I mean, not typically, you use a single endpoint in GraphQL. So you don't have all of these HTTP caching in place with GraphQL, which you can do with REST. So because ultimately all the data is going to be sent through your payload, and you're going to use a single endpoint. So there is no point in caching the HTTP endpoint itself. But there are other ways you can cache the request. You can use persistent queries. So all of that can be done. So and then you have to worry about query complexity. So for instance, as I showed you, so you can have multiple levels of nesting in GraphQL, and there can be n levels of nesting. And as and when the number of levels of nesting increases, the complexity of the query increases, because you have to do a lot more CPU complex tasks, right? And not just that, it's also about the computation you need to do to retrieve the data. So GraphQL talks about the business data graph, as I would say. By that, what I mean is, so you don't expose the technical complexities behind the scenes. So you might have named first name as first underscore name in your database, but that doesn't matter. What matters is what you want to expose to the clients from a business perspective. So if you think that, okay, I need to have a user, and he or she needs to have first name, last name, and all of the information related to it. So I just define the respective schema, and I define all the fields which I have corresponding to that respective schema without worrying about the technical things behind the scenes. I mean, I don't worry about what database I am using. I don't worry about what I have named, what the field name is behind the scenes. I don't worry about what data source, the number of data sources I have behind the scenes. So it abstracts a lot of things. But along with it comes the complexity as well, because you don't know how many queries you're going to make to get that respective information. Then you have complex boilerplates, as I told you. So yes, GraphQL provides a huge amount of power to the clients, but that does require a significant amount of work to be done on the server side. Yes, there are tools to make the job easier for you, but that doesn't mean that the complexity is reduced. It's just that it has been made easier for you. And then you can distribute data graphs. So if you are using a microservices architecture, you can put one data graph for every microservice. You can use Apollo Federation or schema stitching to basically help you split one data graph across multiple different microservices. So if you are working with multiple teams, so GraphQL to the client is always going to be a one schema or one endpoint, right? So you are not going to worry about, the client is not going to worry about what team maintains the respective data graph, or what the data, where the data is coming from. What they worry about is just getting the data from a single endpoint. But that comes with behind the scenes, that comes with a distributed architecture as well. So as you scale, as the number of teams increase, you need to distribute the data graph across multiple teams. So these were some of the technical problems I talked about. There are more which I have written in my blog, so better have a look at it before you jump right into GraphQL, because you don't want to go in the middle and get stuck, right? So better have a look out for all of these. But are all the problems technical in nature? Not all, because it needs, GraphQL requires a change of thought from an organization perspective, and that's why people at Apollo have made a great website called principlegraphql.com, and you can have a look at it, where they say what are the various things to keep in mind while you build a data graph architecture, distributed data graph architecture, which means, okay, worry about the business terminologies, not the underlying technical complexities. Take care of what do you say, a federated architecture, or have a distributed architecture. So they talk about all of these in the Principal GraphQL website. Better have a look out for it, where they will talk about the ways in which any business. So GraphQL is not just a tool for developers, but it's also a tool for the business and the product manager around. So because it gives a better sense into the data which your business collects. Almost every product collects data, right? So it is important for you to understand what the underlying structure of the data is, how you want to architect your data for the organization before you jump into GraphQL. So yeah, now let's talk about a fully typed GraphQL based architecture. By the way, before I go on further, so if you have any questions, so feel free to drop it down in YouTube chat, or send me a PM. So I will be glad to look at it. But in the interest of time, I'm moving forward. So let's talk about a fully typed architecture. As I told you, GraphQL is fully typed, right? So you have a strict schema in place. You have strict data types which you have to follow, and that is a great advantage because you get the power of IntelliSense validation. So it is better to have the compiler do all the work for you, or the editor do all the work for you, rather than you doing all the work. So that's where it really plays a major role, a fully typed architecture, because you as a user may make a mistake sending a string where the expected type is an int. But having a fully typed architecture will avoid such kind of mistakes. Not just this, it will also help you, give you things like autocomplete. So if you are, say, wanting to know what are the respective fields supported in user, rather than going to the documentation and looking up all the fields, you can just use the autocomplete which it provides. And there are a lot of other things as well which it supports. And it's not just for you, but also the tools you use with GraphQL. So as I told you, GraphQL provides introspection, so you can use introspection to do all of it. So that's why a fully typed architecture is really important, because you have an end-to-end validated system in place where you don't make these kind of silly mistakes, because one small type change can cause a myriad of failures across the stack. So you want to avoid that, and you want to make the developer experience great as well. So this is why Johannes from Prisma, CEO of Prisma, had actually talked about a fully typed architecture in one of the sessions. I have just took a snip of the same. So you have a front end, you have a GraphQL gateway where all the front end queries, and you have microservices, each with its own APIs. In this case, it is GraphQL APIs. It can be REST as well. And you have a DM, data management or data model in place, and you have a data access layer. So data access layer is where Prisma comes in, or GraphQL mesh, which we'll be talking about, also comes in. So, or any ORM for that matter. So Prisma, GraphQL mesh are ORMs. And you have a database. It can be anything. So in case of Prisma, it supports multiple databases. So, and same with GraphQL mesh, it supports multiple data sources. So you can have multiple data sources underneath. And this is how what you see in right is how I have architected in Time Campus. So my database is dgraph, which is GraphQL native. I use GraphQL mesh as my ORM. I use TypeScript and TypeScript CodeGen to do all the typing for me. So we'll talk about all of that as we go along. So now, before we get into the tools, let's quickly look at how you go about architecting a GraphQL app. So there are a few questions you need to ask. I won't go into all these details completely, because we don't have time for this. But you need to see, okay, do you need monoliths or microservices? Do you need VMs, containers, or bare metal? All of these questions will also decide the way in which you would want GraphQL to be architected. Because, for instance, let's say you want monolith. If you're using a monolith for your architecture, then you don't need federation, you don't need schema stitching in GraphQL. So you just have you don't even need a GraphQL gateway. All you need to do is have a single GraphQL server, and then just query that whenever you need it, or do mutations on that. By the way, by mutations, what I mean is if you are doing any operation except query, so creating, updating, deleting, those are all mutations. So yeah, by microservices, microservices do require a distributed architecture, because you don't have a single point where you can query. Yes, you can have a single GraphQL gateway and then multiple microservices, each talking with gRPC. But yeah, it depends on how you architect, because ultimately that's what I'm trying to say. All these would decide the way in which you would want to architect GraphQL. So VM containers or bare metal, Kubernetes Mesos, Swarm or OpenStack, scaling needs, because the more you want to scale, the more you need to see, because let's say you have microservices running behind the scenes and you are using GraphQL for communicating between microservices. Now, GraphQL is protocol independent, right? So you can use GraphQL across gRPC, you can use GraphQL across HTTP. So the inter-microservice communication has to be decided based on the performance you expect out of your architecture. So if you want high performance, then it is better to go for things like gRPC or HTTP3, which is in the line. So yeah, so all of these are some things which you need to keep in mind before you start with GraphQL. So this is pretty much the checklist I use, and I have basically added all, I'm not going to read this out, I have added all of this in the blog which I have written, so you can go and refer that. But before selecting any tool for my architecture, so these are all the questions I ask. So does the tool solve my problem well? Does it have the right licensing model? Is it open source? Is it supported by the community? How many downloads it has? So all of these are some questions which you need to ask before you jump into GraphQL. Because once you choose a tool, yes, you can change the tool, but it is difficult to change the architecture. So you need to keep the architecture in check, and the tool can evolve over time. So ultimately, what I would suggest is pick a tool which is adaptable to change, which doesn't lock you in. So that would be a best start for you. So we have talked about all of this, but now starts the journey with the GraphQL ecosystem, and that's why I have this disclaimer in place. Better not get too overwhelmed by what GraphQL has to offer you, because it has a lot to offer you. So let's quickly jump into it. So the first one would be VS Code itself. I'm not going to talk about VS Code, don't worry. I know all of you are developers, so you use VS Code every day, but GraphQL is one of the powerful extensions. So VS Code GraphQL, Apollo GraphQL, these kinds of extensions do provide powerful IntelliSense support, code navigation support. They provide, configuration. So in case you are using VS Code GraphQL, you can also execute queries and mutations directly from GraphQL. Directly from VS Code. So you can do all of that. And the reason why I have put VS Code at the first is because that's pretty much where we developers live and breathe, right? Okay, you might be using a different editor, maybe Atom or something else, but yeah. So what I'm trying to say is VS Code would be the first platform, and all these extensions are already available. So for instance, you can prettify your GraphQL schema using Prettier. So you can have linting rules in place using GraphQL ESLint. So VS Code GraphQL can basically provide you all of these autocomplete and everything. So yeah, that's VS Code for you. So now the next thing which you need, important thing which you need is, so if you are using GraphQL and all the tools and ecosystem around it, you need a way to configure your schemas underneath. So you need to you need a way to define, okay, where does your schema lie? So what are the various ways in which where does my documents lie? Where does my fragments lie? So what are the ways in which I want to use GraphQL? Like, do I want to generate TypeScript code out of it? Do I want to probably use it in a modular fashion? So all these configurations will be basically done in GraphQL config. It's not a norm, so you can use your own configuration to do it. But the reason GraphQL config really shines is because you get a single tool or a single place where you can specify all the GraphQL configuration, because all the tools which build around GraphQL will need the same information, almost the same information, to identify or provide features like autocomplete or anything for that matter. For instance, unless any tool knows your schema, either through introspection or by directly specifying the GraphQL file, they won't be able to provide the powerful features around GraphQL which they are providing today. So that's where you get all the data types, right? So GraphQL config is like a single way to provide config for all the tools around GraphQL. So this is pretty much one way to specify, where I have said, okay, this is the schema I need. I have specified the wildcard. So I want to use GraphQL code gen, which means that I want to generate TypeScript types out of GraphQL. So I have said that, okay, generate the types for me and use all these plugins to generate all the types. So this is what I mentioned. And you can specify multiple projects. And for instance, VS Code GraphQL uses GraphQL config to do all of its powerful stuff. So VS Code GraphQL is one of the tools which has been now donated to the GraphQL org. It was made in Prisma initially, and they donated it to GraphQL Foundation. It's a really powerful tool. It just needs a bit more maintainership from the community, but it's really amazing. So you can say, okay, this is all the type I have. So it will provide you linting. It will provide you, schema highlighting or syntax highlighting, code navigation, and all of that, autocompletes and everything. So now coming to the next tool in the ecosystem. So I understand I'm taking you through all of these tools. The main reason is to explore all these tools so that you can fit them right where it is needed to be fit. So in a typical workflow, what you have is you define your schema, a GraphQL schema to define your data graph. So once that is done, so you basically say, okay, these are all the operations I want to perform. So you define the resolvers, you define your GraphQL server, you also define the rules you want in place so that you can establish consistency among multiple developers in multiple teams. So you need to do all of these to get a proper GraphQL architecture in place, right? That's where you need all these tools. So next would be GraphQL ESLint. So it's a new tool from the Guild. GraphQL config was also from the Guild. And what GraphQL ESLint does is it basically, it's a plugin for ESLint where you can define all the various rules or conventions which all the people must follow to when they are defining GraphQL schemas or when they're defining queries or mutations, so that you have consistency, or even if you don't follow consistency, there is a tool watching out for all of this. So you can say, for instance, you can specify that all the operations must have a query name or mutation name. So you have no anonymous operation, require deprecation reason. For instance, you can deprecate a field without even giving any reason on why it is deprecated. So you have to be providing a deprecation reason, otherwise throw an error. So you can run all these rules through GraphQL ESLint. Next comes GraphQL Inspector. So GraphQL Inspector is where you assume that you have set up a GraphQL schema, you have defined the queries, mutations, but now you want to understand how many operations actually use that respective field from the schema. I mean, I had defined this field in the schema, but am I actually using it? That's where you have GraphQL Inspector helping you, like saying it will help you with coverage, and it will also help you with similarity. For instance, if you have similar operations, a lot of duplicates, so it uses the name to find out similar duplicates. So you can remove it if, what do you say, you are repeating the same field multiple times, or same operation multiple times. So and GraphQL Inspector can be run as a GitHub app as well as a in your own CLI. So there are multiple ways to run GraphQL Inspector. So in case, let's say that you want to send a pull request and you want to make sure that all the schema is validated, it follows all the coverage rules. So you can do it all through GraphQL Inspector. And then I've added TypeScript as well to the stack, because now all the tools I'm going to talk about from now will actually use TypeScript as a base, because TypeScript is a powerful tooling from Microsoft, and you might be already using it already. So I don't want to talk so much about it, but like GraphQL, it provides a strongly typed system for all the editors and plugins to use, and the developers' life is also made more easy. So you have IntelliSense, you have powerful type system, you have syntax validations, and you can code in the bleeding edge JavaScript syntax without worrying about the compatibility. You can do a lot of other stuff with TypeScript, which I can't cover in this session. And in fact, if I'm not wrong, there is a TypeScript Berlin Meetup as well. So you can probably join that meetup group as well if you want. So next is GraphQL Helix. So I don't know if you would have heard about it. So a lot of people use Express GraphQL or Apollo server for the GraphQL servers, but GraphQL Helix is a new entrant in this area, where it's a GraphQL server basically, but a modular GraphQL server. So you don't have to worry about all the complexities behind the scenes. Rather, you can just use those features which you want from GraphQL. For instance, let's say that you are not using Apollo Federation. You don't want your Apollo server to also include all the code related to Federation, right? So and not just that. So let's say that you are not using the Apollo stack itself. So but Apollo server will add all the boilerplate as well, because it needs to work with the suite of Apollo tools. And not just this, even if you're using other GraphQL servers for that matter, be it Mercurius, be it Express GraphQL, they come with all the features inbuilt. So, but what this does is it comes with just GraphQL JS as a dependencies, and it works across multiple frameworks. It doesn't. Express GraphQL works only with Express, right? So, if you want to use with some other framework, you need to watch out for some other GraphQL server. So this works across multiple frameworks, is modular, and you can scale as you go. It supports all the bleeding edge things like subscriptions, live queries. You have support for all of the things which you have in GraphQL, and it has only GraphQL JS has the dependency. Next tool in the stack which you're going to look at is GraphQL CodeGen. So what GraphQL CodeGen essentially does is, based on your GraphQL schema, it helps you generate all the TypeScript types out of GraphQL schema. So it essentially helps you write TypeScript code without having to define all the types yourself. So if you're working on your TypeScript code, you pretty much use typing, right? So interfaces, classes, you define types. So rather than that, since you have already defined all of that in your data graph, which is your GraphQL schema, you can use GraphQL CodeGen to generate all the other things for you from there. So GraphQL modules. So if you are using a microservices architecture, it's pretty much evident that you want a modular architecture. But even if you are not using microservices architecture, you might want code isolation. Today people talk about monorepos, right? So you want to have single repository with multiple packages. So and it can be a monolith as well. And if you're using a monolith, still there is nothing wrong in splitting the code. In fact, it is highly recommended that you split code within the monolith so that later if you want to transition to a microservices architecture, you can. So this is where GraphQL modules really help, where it splits your application into modular structures with each having its own schema, with each having its own set of resolvers and typings. So this way, even if you want to share this module with some other module, you can do it. It supports dependency injection, so you can do that as well. So GraphQL module is a way to split your GraphQL server, single GraphQL server, into multiple modules. So yeah, and this is pretty much how you use it. So for instance, if you want to, let's say, get a typing for your context, you can do that through GraphQL modules. If you want to, let's say, get the provider. So the classes are called providers because it provides a lot of types for you, a lot of functions for you. You get the provider and you do a lot of operations on the providers. So this is how a single module looks like. For instance, I just defined the resolvers which are related to this module. So I don't want to have a single file with huge number of resolvers as I scale the app, right? So it helps you split your apps into multiple chunks. Then comes GraphQL Mesh. So GraphQL Mesh is pretty interesting because it helps you leverage GraphQL without even having to transition all the code behind the scenes to GraphQL. For instance, you might be running gRPC code behind the scene, or you might be using REST APIs already behind the scenes, or you might be using an SQL database or event queues. You can just put GraphQL Mesh on top of it. So it will act as an ORM or an abstraction on top, and GraphQL Mesh will take care of the GraphQL part of it. So it has an execution engine as well. So once you define or it defines the GraphQL schema automatically based on the architecture behind the scenes, and you can modify that as well with configurations. And once you do that, it basically takes care of distributing the operations, queries, and mutations across multiple such services. So there are a lot of tools like this. I don't want to go so deep into it. GraphQL tools you use for doing things like schema stitching. You use it for other operations behind the scenes. Then type document node you have for typing all your queries and mutations on the client side. So in case you want to use let's say a respective you want to do a respective operation on the client side, all you do is you just define a respective type and you define the variables, you get IntelliSense for that. So yeah, basically you can generate all the documents out of existing schema and your client can basically query that. dgraph is a GraphQL native graph database which I use in Time Campus. So that's something which I had a talk or meetup about dgraph before, so you can check that out for more information. GraphQL is the IDE I showed earlier, which basically provides you autocomplete, IntelliSense, documentation, all of that behind the scenes. And GraphQL is not a single tool for that matter. By that, what I mean is it's an ecosystem of tools. So you have lot of plugins or packages running behind the scenes. For instance, the GraphQL language service, which provides a GraphQL specific service, and you have plugins which provide functionality for each and everything you are doing with GraphQL. So, and even other tools, not just GraphQL, leverage those same kind of ecosystem which GraphQL uses. So GraphQL acts as a first implementer for all these plugins, and once GraphQL has implemented them, the other tools also follow pace. Another tool I want to mention here is there's Playground from Prisma team as well. So that's also pretty good. In fact, GraphQL and Playground has joined forces recently. And then there is GraphQL Explorer. So if you have a schema and if you don't have developers who understand GraphQL, or you are starting off with GraphQL, or even otherwise, so if you want to have a simple way to define your GraphQL queries and mutation by just checking the boxes and running the operations, GraphQL Explorer is one such tool where you can just check what you need and then query it. And GraphQL Explorer will get the data for you or define the queries and mutations for you. Then you have GraphQL Voyager. So we talked about introspection, right? So GraphQL Voyager uses this introspection and basically generates all these data graphs from GraphQL to understand. So this is like a ER diagram, right? So what are various entities? How do they relate to each other? And what are the various fields under those entities? So all of these is provided by GraphQL Voyager. Then you have GraphQL Upload. So you have HTTP file uploads. Similar way, GraphQL also has a way to upload files and documents, but that is not part of the same spec, but rather there is a parallel spec called multipart GraphQL multipart spec, which you can use to upload and download files from GraphQL. Then if you are using real-time updates or real-time changes to your GraphQL server, that's why you have GraphQL WebSockets. So you can GraphQL WS will help you add a real-time update or change feature to your GraphQL servers. You have Apollo Federation, which helps you distribute your data graph across multiple microservices. So each and every microservice can own a part of data graph, and then ultimately the users can see a single graph where you have all these in place. So this is Apollo Studio. It's a proprietary tool, not open source one. So, but still, it provides powerful tooling for GraphQL to explore the schema, to view the change logs, and do all of the things with GraphQL. I added Gatsby here because it pretty much uses the power of GraphQL to talk to multiple other plugins. So you define all of the things, all of the data in GraphQL, and that's what Gatsby uses underneath to do all of its operations. You have OpenTelemetry, which you can use to do instrumentation and tracing, distributed tracing of GraphQL resolvers. So if you are using GraphQL server and you are using multiple microservices and you want to trace the GraphQL request across multiple microservices, so you can do it all through OpenTelemetry. So recently it has been merged from Open Tracing and Open Census. Initially they were two separate projects, but now it has been merged and there is a new GraphQL spec out there. I will provide all these slides for you. You can actually go through all of this later as well. Then you have GraphQL Faker, which is basically a tool which helps you mock data based on your GraphQL schema. So if you have a string, it will provide you a way to expose all the string types. So if you have an integer, it generates random data which you can use rather than having to define all the data in your database and then working through it. So rather, you can just say, okay, this is the type of data which I want. And just get it for me, and it will go and generate all the data for you behind the scenes. For instance, that's what we are seeing here. So Ivan and the pet image. And yeah, I would like to probably stop here. So this is how a typical GraphQL workflow looks like. So you do evaluation and research, get your boilerplate ready, you put together your data graph and documentation, you deploy it, mock it. So there is a typical workflow which you want to use with GraphQL. I have outlined this in the blog which I wrote, so you can have a look at it as well. I know I went at a huge pace. Probably if you're a beginner, you might not have understood everything, but it's a start. So you got introduced to GraphQL. But if you are not using JavaScript or TypeScript, almost all the tools I talked about today was related to JavaScript or TypeScript, right? There are other tools, similar tools in other languages as well. And if you want to have a look at it, you can go to graphql.org/code. And depending on the language you use, whether it is Golang or Rust or Java, whatever it is, so there are tools available which does similar things, but may not be exactly same, but it does a lot of stuff for you. So you can go and check it out. And thank you. So this is where you can reach me. So in case you have any doubts, questions, and probably the next time, maybe some other time, we can probably go a bit more deeper into GraphQL. But yeah, thanks for that. Hi, Daniel.
Hey, Vignesh. So thank you so much for that insightful talk. And we already have some questions from the audience. So Marisa asked, is GraphQL for smaller scale project or bigger scale projects? Do you want to chime in on that, on how to approach that in such situations?
Sure. When you are starting off with GraphQL, so GraphQL is meant to be incrementally adopted. So the scale doesn't matter. So if you are in a smaller scale project, you don't need all these tools in place. You just need the minimal number of tools to get started off. And as you scale up, you can probably add more to the ecosystem. So it does cater to all these architectures as well.
Got it. Okay, so on that note, there's no more questions from the audience.
Thank you. So it was nice meeting you all.
Thank you so much, Vignesh.
Thank you.
Okay, so we had another question about Prisma Migrate, and we will address that perhaps towards the end of the meetup, or I'll reply in the background. And now we're coming to the first part, the first section of our quiz. So let me just advance the slide here. It seems that something is eating up my CPU and slowing my computer down. So I'm sorry if there's a delay there. And now I'd like to invite you to join the quiz. So you can join it by going to slido.com/graphql or by scanning the QR code. So the first question that we have is, what are the basic data types supported out of the box by GraphQL? We have four possible answers here. First one is geo, int, float, datetime, boolean ID. The second is float, string, int, boolean, and ID. The third is geo, int, datetime, boolean, and char. And finally, the fourth option is int, char, float, datetime, and boolean. So you should be able to already submit your answers. Okay, it seems like everything is rather slow here. Really trying to fix this. However, it seems that this is beyond my control right now. So okay. Let's move on to the next question. So indeed, the second option was the correct one, float, string, int, boolean, and ID. And 80% of you got that correct. Let's see if we can advance this to the next slide. Okay, so we come to the second question. In a well-designed schema, if you were to retrieve the profile info of users, their friends, their posts, the comments to the post, and the URL of the respective profile photos, what is the minimum number of HTTP requests with which you can do that in GraphQL? And now the quiz should be open. Oh, let's see. Okay, so it seems like we're having a lot of technical difficulties right now. I suggest that we bring Dominik to the stage, our next guest, while we figure out the technical problems. So, in case you're not familiar, Dominik is the author of a new book about GraphQL in German.
Hey there.
And the name of the book is in German. It's GraphQL, Eine Einführung in APIs mit GraphQL. So an introduction to APIs with GraphQL. And I would like to bring
So yeah, hey Daniel, can you hear me? Does it work out? I currently can't hear you if you can hear me.
Oh my goodness, we did not prepare for that. Hi everybody, I'm Natalia. I'm an events manager here at Prisma. So it seems that Daniel's internet is just not there for now, and I will just carry on. So Dominik, congratulations on your book. Super well done.
Thank you.
Well, lovely, and thank you for dropping in and joining us. Let's just have like a tiny bit of interview. It won't be as good as if Daniel was here, but he prepared a couple of questions. So I'm hoping to deliver them in a way that would enrich in the meetup. Cool. So maybe let's start with what would be the common pitfalls when starting out with GraphQL? What challenges could the new developers face when trying to get into GraphQL?
Yeah, so yeah, sure. Vignesh talked already about a lot, really a lot of pitfalls that you can have with GraphQL. He did a really, really good job in covering basically all of the topics about GraphQL.
Thumbs up, Vignesh. He's smiling from the backstage, I see.
Yeah, so it's hard to find a new topic to talk about now. But yeah, sure. I think the first biggest issue that newcomers to GraphQL always have is an easy one, because GraphQL is not REST, and I also think GraphQL is not the next REST. In general, I think that the time that we have only one tool that fits every solution
Right.
is over. And I think especially with REST, if we think about APIs, we always think about REST. And I think that's over. We have different solutions for different problems, and GraphQL is one solution for one specific problem, or well, a lot of problems basically, but it still has its specific use, and that is when it comes to complex data structure, and especially fetching complex data structure that is quite encapsulated like a tree. If you have a complex tree structure of your product that you want to fetch in one call, GraphQL is perfect, but especially I'm really always struggling a lot if you have a lot of mutations, especially a lot of mutations, so manipulation of data in lower levels of your data, because in those terms, you have a lot of different methods and different functions covered in your mutations, and that can blow up your whole schema a lot. And I think so. The first pitfall is always keep in mind that GraphQL is not REST, and GraphQL is not the solution for every problem. So get to know what is exactly your problem, and then think about if GraphQL really solves this problem in the best possible way, or if there is another solution for it. But if you answered that correctly, GraphQL is the answer for my problem. You still have to switch your thinking a bit when you come
that's
in,
usually the case.
Yeah, especially if you started with REST and then you start up with, now my next API will be a GraphQL API. You have to start thinking in graphs and no longer in individual resources. Again, Vignesh did a great comparison between what REST APIs do and what GraphQL does. And again, it comes up to your data is no longer structured in a flat way. It is structured in a tree. It is structured in a graph. And having a lot of references, like especially ID references, built into your schema, and then forcing your user to use that ID reference to fetch another related object is not the correct way you should work with GraphQL. You directly can nest all of the objects within one call, and that makes GraphQL really awesome. But it really is, a different thinking in that way. And yeah, there's a lot to think about. For example, if you look at the schema where you can have those encapsulations, that also leads to having a lot of options on how you can fetch your data. And with that high power that you give to your clients, you also have those clients also have a lot of responsibilities, and you have a lot of responsibilities, because your schema is at the end the one source of truth about how you can explore your GraphQL API. And I think if you have some naming problems, some unmatching pattern or something, that is not that big of a deal breaker in a REST API. Because at the end you still have your list of individual endpoints you can just trigger. I think if you have an inconsistent naming pattern within your GraphQL schema, that is something that is always a big problem. And I think, especially if you're beginning working with GraphQL, you should definitely put a lot of focus on naming. As the old saying goes, the hardest things in IT is naming and caching. That's especially true for GraphQL. Yeah,
thank you for that. I see that Daniel is back. Let's see. How are you feeling, Daniel? How is your bandwidth?
This is probably the worst nightmare that can happen during a live
Isn't it just? My thoughts exactly.
But worry not, Prisma does finance the highest equipment. I'm running a 16-inch MacBook Pro, the latest and fanciest one. So I'm sorry about that, but we're back. Thank you so much.
I'm happy that you're back.
Gracefully.
Okay,
I can also say you handled it perfectly.
Go back to the dark of the backstage where I'm feeling the most comfortable, all right?
Thanks.
So I believe that Natalia already asked you a couple of questions, and I probably missed a lot of the interesting answers. So,
in fact, she just asked me one question, which was the first common pitfalls you have when you're a beginner with GraphQL. One of your prepared questions. So you handled that really good. So don't be too hard to yourself.
Yeah. Okay. So I have some more questions.
Sure.
And the first one, when it comes to GraphQL, what are some of the testing approaches that you recommend when working with GraphQL?
Mm-hmm. So looking back at Vignesh's presentation again, like GraphQL is basically built up in in a, you have your schema, and schemas have objects, and those objects have a huge list of fields. And at the end, your GraphQL, server is just resolving every individual field in a function that is called the resolver. That structure that GraphQL delivers to you is basically already a first good point to start your testing, because at the end, every individual field is a resolver, and every resolver is a function, basically. So you can have a very good unit testing with it, just to test your individual endpoints, so to say, your individual fields within the schema. And there are so many test tools to just do that. Like Jest is one of the Node.js test tools I always use to basically test my resolvers, which are just functions. So use whatever there. And if you go one layer beyond that, there's also, you can just have some basic HTTP testing tool, again on Node.js, like Supertest, which you can use in order, to have some basic queries sent against your GraphQL API, some good cases, some bad cases, and then you make sure
it would be like integration or end-to-end tests, because you're already testing this at the HTTP layer.
Yes. So since you have your unit test on the one side by testing and the resolvers and then mocking the services behind that, it's always a good approach to also have at least some happy case tests for the GraphQL API at the end. It has one good thing. When testing your API, your GraphQL API, you only have to test one endpoint. That's the good thing. The bad thing is that one endpoint can be really, really complex. And one good tip I always have when starting with GraphQL and working with GraphQL, especially when you're working with JavaScript, is always, if you have a problem, Apollo always has a framework to solve that problem. And so they also have a very good testing framework to test your GraphQL.
And I guess that speaks to the relative maturity of the GraphQL ecosystem in JavaScript compared to other languages, right?
Yeah, in general, the GraphQL community is one of the best communities I ever participated in, as you can see in the meetups along. But if you look at the documentations, if you look at all of that, I don't know why I wrote a book about it. It's you can get everything in the internet. Alone looking at, for example, one of the good examples is Shopify. Shopify also uses GraphQL, like really, really major levels, and they have so good documentations about how they handle GraphQL and how they solved issues, and really helped growing GraphQL a lot.
Got it. Thank you so much, Dominik Kress, for joining us today. Sorry again for the technical difficulties.
No problem.
And we hope to have you soon again on this meetup.
Yeah, thanks for having me over. It was a pleasure.
Great. So I think what we'll do now is we're going to retry to do the quiz so that we can retry it. So I'm going to try to share my screen now for the second time. If you haven't already, I know I've said this a couple of times, feel free to join us on the Slido. The Slido hash is GraphQL. So you just go to slido.com/GraphQL. And I believe that we've already looked at the answers to the first question. And Tobias was the leader. He got this within 21 seconds. I should point out that the quicker you answer questions in the quiz, the higher your ranking will be. And I believe that we also had this second question. And indeed, that was a single request that you need in order to fetch as much data as you need. And now we come to the third question. Which of the following can be used as ORMs to work with underlying data sources in GraphQL? And so I invite you to join this and submit your answers. We already have, I see 6 responses coming in. I'll keep this open for another 30 seconds or so, just to let all of you get your quiz game going. Let's see. I'll count down from 10 before we close the poll, and that will be 10, 9, 8, 7, 6, 5, 4, 3, 2. Okay, let's look at the answers. So indeed, it's GraphQL Mesh and Prisma. Most of you guessed that correctly. Now we come to another question. How does GraphQL Voyager retrieve information about the underlying GraphQL schema? So we have the first option is schema querying, introspection, schema stitching, and subscriptions. And on that note, we'll close it. Indeed, it was introspection. Most of you got that correctly. And this is going to be the last question of this section. And then we're going to have later on another section of questions. So which of these protocols are supported by GraphQL? HTTP, the first option is HTTP, RPC, and WebSockets. Second, HTTP and WebSockets. Third, HTTP WebSockets, WebRTC, and RPC. And finally, it is protocol independent. That would be the fourth option. So 65% of you voted for it is protocol independent, and you are correct. It isn't dependent on the protocol. And now we're going to wrap up, and let's look at the leaderboard. So Tobias is still leading the charge, followed by Michael G. and Matthias. So congratulations, you're leading. Let's see if you manage to make it through the second section leading too. And now I would like to, I would like to first of all remind you that this meetup is organized by Prisma. I know many of you know that. We recently just launched a new Udemy course, and we'll share the URL for that. This is an end-to-end React with Prisma, this course covers GraphQL 2 and building a front end with Next.js. I highly recommend it. The course is by Dr. Stephan Jensen. He's a great teacher. And the next thing is that tomorrow we'll also have the What's New in Prisma live stream, where Nico and Ryan, my colleagues, will be discussing a lot of the exciting new features that we just released in the 2.16 release. And now I would like to invite our second speaker for today, Stephan Schneider. And Stephan Schneider is going to talk today about ramp up your GraphQL learning experience with data you already have. In case you don't know Stephan is a backend developer at Contentful since 2018. GraphQL is not just an interesting technology for him. When he started participating in the company's initial development of their first GraphQL API. And he has not stepped back since, and he constantly plays with new ways to integrate pre-existing data with GraphQL. So without any further delay, I bring you to the stage. Stephan.
Hi, thanks for having me.
Hi, Stephan.
So let me get my screen share in here. That should be visible now, right? Cool.
Great.
So yeah, let me get my speaker notes up here as well. So sad that I won't be seeing all of you then. Cool. Yeah, so this talk is, the title already says, is about how you can use the data you already have, meaning some data from like maybe some pet project or even like from your company or whatever that is already existing, and you like want to expose it with GraphQL because seldomly you like really create like a new project with like a completely new data set, or if you do, it happens to be like quite overwhelming. And so the first thing is like how do I actually get to that point here? So in the beginning, I was working with GraphQL, just like like reading an example tutorial here and there, But then eventually went like with the company for GraphQL, and there we had like different things that we actually needed to try out and needed to do, and I'm like to like apply technologies with like specific questions in mind or like problems that I have, and so just doing like something else, like a small starter, and just like learning how to query the data with it was just not sufficient for me. So why don't actually want a starter here? It's like, yeah, starter's a great way to show like a specific way of implementing something, and like to scaffold stuff. Like you want to wire up a Gatsby project, you know, you have some content provider, some styling, some default functionality that like tracking or so that you want to combine together. And there it's like really good to have like a starter that gives you something. But if you really want to understand the technology and want to reuse it afterwards and you know, really master it, I don't think that this is really giving you much. And so I was like then being asked by Stephan Hiatus at some point, like, you know, a developer relations person from Contentful, who is also very active in the community. Maybe some of you know him. And he was like reaching out and asking, hey, you're like doing so much with GraphQL. What are actually tutorials that you like? And I didn't have an answer to that, like really not, because I was never really following it. And I was like, why don't I actually encourage more people to try it out with your own data? And that's what I'm here for today. So I want to encourage you to try it out with data you have, to like prove to your project or your company that GraphQL is a good option to choose here. And therefore, we're not using a starter because that just shows that a project works, like GraphQL itself works. And it's more about like you querying the data. And we are going to show you how we can do that for your use case so that you can actually get going and understand the underlying functionality. So you could argue, well, I can do the same thing with just like to-do MVC or a simple block example. You know, I can still build that from my ground up, and yeah, you can do. It's not specifically thrilling, if you ask me. I don't really get my dopamine out of it. If something works, it's not really, you know, my brain doesn't really know what it was expecting for you to see when you get the first time results, because it's not your data set. If you have something you're very much, you know, in love with, or you at least know the data shapes, then you see some data and you know directly or immediately like whether that's what you were expecting or not. So like the feedback loop for your brain is also a bit better. Also, like to do MVC, yeah, you can compare it quite good with other implementation. So if you are there for like, I want to show off a new project like Helix or Nexus or whatever, and I want to show that it works or how it works, then to do MVC is a great thing. You can just jump in there and you have a specific feature set you can replicate, and then you can compare it. And I think that's the difference here. Like if you're just doing it for yourself, like some kind of like intrinsic motivation, you want to prove to yourself that something would work with GraphQL for your use case. Then you're doing it like for yourself, and only you need to work with it or understand it. Maybe some people from the company want to pitch it to. So it's like more intrinsic motivation. Extrinsic motivation would be for me here, you want to like showcase it. You want to put it into a blog article everyone should read, no matter whether they know your data domain or not. Then like having something very easy to understand, like a to-do MVC or blog, is like a very good and cool thing. So it's not like, you know, fighting for like doing it either way. It's just like what you want to achieve with it. So pitfalls, because we all like to know about pitfalls up front, right? And usually projects tend to go into two different directions. Either they generate no code for you at all. I will show you that in a second. And to me, I then struggle to understand what is actually going on in the background. And you don't really see the schema, or you don't learn too much from it. Or you just like generate it for all the data you have, depending on what kind of data source you take. That can be a lot of code that gets generated. And initially, you don't really understand what it's doing, and you might not want to have that. Because you then need to touch all of them to just get your if you need to adjust it. So for me, that's like also very overwhelming. Then you just have like, okay, it just generated me dozens of things. What is it actually doing? And then also you might have like some incompatibilities. Let's say you use some character that is not allowed for a GraphQL type name, and the tool doesn't catch it properly or so, then probably the whole graph generation will just fail if you want to use it as a schema. And there's usually not a partial generation you can do. So what can be those kind of things where you need to do that is, 1 second. So for example, if you say you have a database already, and on the database, you have like all the data already. So you're generating it from that database, you're getting the code generated, and then you look at it and see like, okay, maybe it fails because there's like an ID field missing or so. We, on our project that I will show you later, have an artist type or an artist object, which has no ID field. It only has like a slug, because the slug is unique to it. So we didn't see we needed to use an ascending integer. But some tools might expect that, and then you actually need to work around that. We will get some tips around how we can do that later. And then the same as Dominik just mentioned, like naming conventions, they might just not match. We will see that on the example with Prisma later on, where I was using like a snake-cased, how's it called, like table naming in a database, which didn't work out without some mapping. It will work eventually. So what I will be demoing right now is Clubnacht. Clubnacht is a project I'm building with 2 friends, or have been building with 2 friends, which is literally just like a timetable app for a club. And some of you might recognize it. Yeah. So that's like from pre-COVID area, obviously, because nowadays we wouldn't need to go there. But if you go on some event, you get here like who is playing, and you can actually do that retroactively, so that you can see it here, and then you can click on people, see when they have played, and so on. So it's also rather simple from the data shape, and we have been building that, and we have a database for it, but we are only doing that on some REST-ish API by now, because it has been a while since we have been working on that the last time. What I want to use for that is Hasura. Some of you might have heard, just like for showing what they are doing radically different than all the others, and whether that's actually good for a learning experience. So let me get terminal window up here. I can, first I actually wanted to show here. Is that visible? I can make it better. Cool. So this here, for example, is the artist table from what I've just showed you in the system, which is rather simple. Here I cannot zoom in. I can. It's rather simple, and here I added the ID actually already. And you have like a name, a slug, whether it is like a resident, which is like some kind of special thing for an artist to be in a club. If you're a resident, you're basically one of the cool guys there. And you can see this is like lowercase here, and on some other fields here is with a snake case. But it contains data where you need it. Oops, you need it here. And we should be able to just generate that data or query from it. Hasura is very simple when it comes to that. If you have a database already, especially Postgres here, as we happen to have, and you can just drop in this command here. You can actually obtain that from their website, which is just connecting to my local database here we are using for the development thing. Once you've started that, it actually in the background spawns your Hasura terminal, how that's called, I think console. Console. Which we told it to be available on port 8080. So if you go to 8080, you can actually see here that it did a whole lot of view already. You have some nice visual. I'll just make that a bit bigger for everyone here to see. You have a nice UI already where you can do things. You can explore already. And how do we actually get the data in? It's by doing it here in the data, you can just go there and say, oh, here, look, we have tables that we are not tracking. So in preparation, I have already clicked here on the track button for the artists. And once you do that, you can already see here data to be previewed. You can modify the schema and edit it. So this here gave you a whole lot of things. So in the end, you can go back here to GraphQL and probably be able to click on here, and you have like already GraphQL API running. I mean, that's pretty awesome for you to get started. But if we come back, like, what have we actually learned right now? We have a GraphQL API, yes, but what do we know about the schema? What do we know about how it was generated, how it works? And do we really now feel like more confident in working with that technology for anything bigger? I would argue no. So there are other ways on how that can be done. And one of that is Prisma, like our host here, hi. And no, I was not forced to bring in Prisma. It just happened to be a very useful tool if you want to work against database data. And especially if you want to have a more precise look on what is going on. Prisma is different to Hasura here in that it doesn't just do a one command thing and you're done, but it actually generates you a schema or generates you files that you can then later on use to query your things while implementing the GraphQL schema by yourself. You can integrate that with other starters or tooling to take that part away from you, but they are not very opinionated around how the GraphQL or the data you expose via GraphQL will look like in the end. And then there are also tools that help you converting JSON shapes to a GraphQL SDL, because you might not just have the data readily available in a DB already. So if you happen to have just like a set of fixtures, you could use the, how's it called, GraphQL JSON server, also I think. But you have to have some very specific data shape that you have to put in there. And it's not really easy to do that sometimes, and other times it might be. So again, here it's more around, it's more around what you want to achieve with it and what exactly you want to learn. For some people, just like showing here, this is how a club timetable API would look like with GraphQL. Hasura definitely is enough, right? But if we want to extend it later on, to example, provide for an artist the next events and so on, we might need to customize something, and we would need to research again how to do that within that system. So you would learn Hasura, but you wouldn't necessarily learn GraphQL. Same could be argued with Prisma, but here it's actually that you don't learn Postgres or SQLite or whatever, but you learn like the Prisma way of how to generate your thing. How you will eventually end up consuming that in GraphQL will be like still up to you. So here, let's do the same thing with the Club nach Prisma client. And here we will actually funnily run into that naming problem, and I can show you how that was actually solved. So here I should actually have, yes. So with a Prisma schema, I will just make that way more bigger for you. So the actual interesting part you provide by yourself is up here in a Prisma schema.prisma file. And we're basically just saying it, hey, go to the Postgres and generate us something for a JS client. Actually, it's a TypeScript client, but well, it's JavaScript at the end of the day. Then within our shell, we have run a command that then inflects the schema from the Postgres database and writes you those Prisma models. As you can see here already, that model is also lowercase, and it contains all the snake case formatting in here. But it actually already looks quite good. You get a good understanding of it, and it looks somewhat GraphQL-ish, right? That's also because it actually is used for that later on. But you want to generate something that is more in the shape of how GraphQL naming works, which would be Pascal case, so an uppercase P here, an uppercase A here, and no underscore in between. Luckily, there is actually a tool that does that for you automatically. I run that over it, and then afterwards it looks like this. And that one here looks already quite understandable to me. And I would feel confident in working with that somewhere within our code base. But mind here, this is like not GraphQL in itself right now here. This is just giving you a nice query layer on top of it. And for example, you could have as well have a corporate specific query layer. We had that at Contentful when we were building something. And then within our resolvers, we were just using our abstraction and could still reuse a good chunk of functionality later on in our GraphQL. Let's go back here. No. Where is it? Here. So after you have actually generated that client, that's what I was looking for. This is the only thing you get. You get like this Prisma client, and then for every type, you get something generated here already. So you get actually type safety. And this one here will take away most of all the things you will ever want to do in the first iteration of a GraphQL API. And for people who are like very, very new to GraphQL, this one here is what we mean like with the resolver and the resolver function that also Dominik was talking about earlier. If we resolve, we have just like this function that will always be something like that. And in here, we can actually use that, that Prisma generated code. What we do by that is we are actually defining ourselves here how the data should be fetched later on. So if we combine that with this schema SDL we are going to generate, then we explicitly define what we want to expose. And I think that is like very, very crucial, and we will get to that later, that you're only doing in the beginning like what you need. And don't try to get like all of your domain into GraphQL at the same time. Try to adapt it in increased fashion and like step by step, and don't overwhelm yourself. In the end, it's always about that you feel comfortable and you feel like you've learned something, because in the end, what gives you the dopamine is like the learning effect. That's how our brain works, and you want to tease yourself a bit, right? We are all at home, you're all struggling. Tease yourself a bit, get some dopamine by just getting success in a new tool. As one might have recognized, in here we currently don't have any data GraphQL schema defined, and this is actually fine, because as I said, we had the REST API already beforehand. So what we can do is we can use another tool that gives us some rough overview of how that GraphQL schema should look like. And this is called transform.tools. It's a very handy website. I can only recommend that for you. Like whenever I need to transform data in between formats, I usually look at that first. And why can't I not move this here now? Well, that's... Oh, okay. Well, this here is the website. Here is my locally running API that is actually serving that. And if we look on a specific artist, we get events. This is basically reflecting right this page. And if we are just lazy and want to have something, we're not so familiar with the GraphQL syntax yet, give us something that we can use to create an event or an artist. Here for the event is actually nicer because it is nested with a playtime. We can just copy the JSON and drop that in here. Oops, like this. And what you will get out is already the GraphQL schema definition language that you can use afterwards with tools like Apollo or most of the other things that Vignesh was like telling you already about. Here we have like slugs being string fields. You could now take that and change that to example be an ID field. So now you have like very, very much fine-grained specific hands-on dirty work with your data. And I think that's really good, because that's where you feel comfortable, you know that data, you probably spot that here right away if you would be in that domain. And also the playtimes here, are like linking already to an array of artists. You get some nice naming actually inferred already. And you can take that and pop it somewhere here, and then later on use it in your types to actually combine that. So you might be wondering why we are only looking at queries here right now. And that is very easy to reason about, but you might still get that wrong. It's easy to, or it means easy, but it's feasible to later on add more things to your GraphQL schema when you proceed. So what you want to do is you want to provide the core use case that you will be doing with the GraphQL API, and that usually is consuming data. You already have existing data that we were reflecting on. So there's like no necessity for you to write mutations to like put data into the system first, just so that you can use it. And actually, it would also be kind of like, you might be overthinking yourself. You might want to like validate all the user input. You might want to do like some roles or authentication or whatever. That's everything not that you should do in your very first attempt on a GraphQL API. You should just get you the best visible result output you get. And for that, you need a query type. Even if you would design a mutation first, you would still need a query, an object type later on to actually get something back from that mutation that you've sent. So when you send a mutation, you also specify a query afterwards that is executed to give you back to see what has changed or the success about it. So you would either way still need to write the query part. So in the beginning, bother with nothing else. The querying is the important one. If you then at some point feel keen and or curious about like mutations, with Prisma, for example, you would be covered. The client would also provide you with methods there, or you can then like step-by-step increase it. Also, very important for mutations, think about it in a way on like what you want to instruct the system to do. Don't do it like in an update X to Y kind of fashion. For, I don't know, shopping, I think Shopify has like this real expressive add product to cart mutation. Then this is like really clear on what you want to do. And in the beginning, you might not know all these use cases that your API will have because you're still thinking like in REST terms or in even other terms like RPC or whatever. And you might just have like those create, read, update, delete scenarios in your mind. And once you work with the data and you understand how they link to each other in the graph, you will think, or you will come up with more specific mutations you can do. That one here I can really not stretch enough. Like, do only what is necessary. Like, yeah, the authentication I mentioned already. Query complexity also is a very good point, actually. Query complexity can like limit the amount of data you can pull out of your GraphQL API. And you might think, oh, like that's super important to show to my company, so I show we cannot be DDoSed or people cannot like abuse us to get like all the data. And yes, that's true, but those things and those scenarios can be implemented later and actually should be implemented later, because in the beginning, again, you're thinking in REST terms, you might not know what is the most best query to get out of it. For example, for our Clubnacht homepage or an entry, in the beginning, you might just say, okay, like I just need an entry, then like an event, sorry. And then once you have an event, you will see, oh, I actually want like the one to the left and the one to the right as well. So you could provide like your previous event or next event also as fields on the GraphQL API. And that increases the complexity of the query you need to do. So design or limit afterwards, like protect your infrastructure, but design for the most clear and expressive query a user should be doing to get the data together. Also, you might be thinking, oh, I need to integrate that within our current infrastructure or something like that. I need to prove that, our HTTP server implementation that we have can do it. And we had the same thing in our company at Contentful, because we are using extensively Harpy for our services. And Harpy is a very good server in my point of view, but it is lacking a very good integration with GraphQL, or has been at least, because as Vignesh was mentioning with GraphQL Helix, you can actually get that with like mostly every HTTP server running. And that, if I would have known that beforehand, probably would have spared me a couple of hours, because I was trying to embed that and it didn't want to work properly. So in the end, we were then using Apollo server, which was just giving us a very good quick start so that we could just get it running. The thing here, to stretch again, it's transport independent. In the end, it's about the schema. You just make the schema accessible via the HTTP server, but as long as you're building and working on your GraphQL schema and resolvers and the implementation, it will work with all the servers you can come up with in the end. You don't need to do that right now. You're using Fastify or whatever, it doesn't matter, just like go for Express GraphQL, go for Apollo server, and have a look afterwards. Oops. Yeah, there are things you should care for in the beginning. And this one here is just like a personal experience. I don't know whether other people were actually struggling with it, but I found that to be like kind of a nice anecdote. And that is the pagination approach. So what I was doing in the very, very initial things when working with GraphQL was just like to have, yeah, like a collection, it's an array, right? So I think even on the GraphQL page, it is done like that you are showing like lists of things as like an array. And that can work, but for most of the real world use cases you have, you need to slice those collections into like subsets you can query, and you need to paginate around them. And this changes how your GraphQL schema will look like. If you don't care for that in the beginning, it is still possible to implement it, but type names change a lot, I figured. Like, at least if you want to keep them consistent and expressive. Because now there's like one more nesting level in between that you need to go down, and that should just be accounted for. There are like two frequently used things, which is like offset-based pagination or cursor-based pagination, and it doesn't actually matter in the beginning which of both you choose, and you also don't need to implement it. Just get the nesting part right. Just make sure that if you are giving us, let's say here, an event, an artist has, events, no, the other way around here. An artist has events. You could say, yeah, okay, that is just like event. That would mean you always get like all the events to it. That is not necessarily what you want. What you probably want is that you have events, which is like an artist event collection. And see, here like things start changing already. And then you have this type here, which has, depending on your implementation, and as I said, you can like just omit that for now, has, for example, skip or limit, or has some kind of like a cursor when you like after. But those things are not important. Important is here that you decide whether you want to go with a relay-based approach or like a usual items-based approach. You can read up on that if you're curious. For now, I would just recommend you just put like here an items in, and then that items part is actually your event array. This way, you can later on decide what kind of pagination you want to have without changing all the things you have done so far, all the example queries you might have shared. And yeah, the implementation for that is very easy, because at the end of the day, this is just an identity resolver here. The items just take the events that were passed and just pass them through. So you don't need to care for that in the beginning. But for me, it spared a couple of hours of work, I would say. Yeah, you might be wondering now, well, this looks like very manual what you're doing here, and you know, why do we actually have all those cool tooling above that like bootstraps us all the project, generates everything, if you're like in the end recommending us to go back and just do it manually? Well, this is not what I'm recommending for everyone, but just if you really want to deep dive into it, like if you really want to master the technique, you want to learn it, you want to validate a specific use case, then the resolver is your best friend. Like, you can do a lot with it, and like also with the type definitions, when you do them with like Nexus or GraphQL Compose, you can do so much with it. And in my point of view, you will only scratch the surface if you're using only generation tools. If you want to get the best out of it for your customer or for your project or whoever, you probably want to touch it to your needs. And for that, these resolvers here are very, very handy. And it would blow up the whole part of the talk, like how to use them properly. But don't be afraid to just have a couple of functions here and there everywhere that are like fetching your data and providing it to you. You will see eventually how to reuse them or how to structure them away for you. And there are probably also other great talks you can have or you can look at on how to do that. But mind that you will eventually need to write these. And there is like nothing wrong with it, and it's like not a code smell so that, oh, I needed to implement like yet another resolver. If you are happening to derive the things from JSON like we did here, probably you don't need to do much with resolvers for your leaf fields. So like the scalar things you have, like start, end, and so on. Those are by default resolved by the name of the field. So if you provide the playtime's GraphQL type, a playtime object, then it will just work and resolve. It will take the ID property if you go to the ID field. And this helps you in the beginning, so you don't need to type them out expressive every time for every single field, but you can rely like on this default field resolver and only care for the juicy parts where you're like, going to the database, fetching your things. And this, my speaker notes are always going away when I flip the things. Yeah, sorry, I hope I have not been rushing too much through this. I wasn't actually sure how much time I just took here. I think it was a bit too much probably. And yeah, like shout out here to our organizers. Actually, with Prisma, it's a breeze to like just use the resolvers. Like just writing them is more or less like a couple lines of code every time, and you get the things out of the database. And I'm very looking forward to actually bring that to Clubnacht. Even though I need to do my own manual mapping to our database schema, I think that's definitely worth it. And yeah, with that, I will conclude and thank you for your time. And feel free to like ask the questions now. And the quiz questions are more or less the things I want you to take away from this. So I hope you enjoyed it, and let's have a chat.
Stephan, thank you so much for that. That was really insightful, and it was really interesting how I think you provided a strategy for anyone to get started with GraphQL today, with the data that they already have. So thank you for that. I think we had one question come in. I'll share my screen. Let's see. I'll bring up my screen. So this was a question that came from Bruce. It came a bit earlier, but perhaps you want to chime in on that, especially since you said, hey, you can just start off with just queries. You don't need to necessarily worry in the beginning about mutation. So having used it in a lot of systems, it's definitely great for read-heavy APIs. Do you see times where GraphQL shines for mutation operations compared to REST and RPC?
I think RPC can be quite comparable to GraphQL mutations, because there you also have more, expressive. What?
Sorry.
So, no, like so you on RPC you also have like very expressive kind of calls you do with like telling it explicitly what kind of action you want to do. And that is what I would say is comparable to both of them. So I wouldn't really say GraphQL shines there. When it comes to updating data compared to REST, I'm still on a split side. So that's why I'm also like probably encouraging people to go with query first, because it depends on what you're working with and the domain you're working in. Like for me, I'm usually thinking in terms of Contentful, because I've been there for like 4 years. So we there want to just like update an entry, for example. So usually you don't cross many boundaries between anything where it would justify having a graph. So, just like doing a REST put to like update it is like totally fine. While when you want to consume it, we're very data graph heavy. Like Contentful is like a graph of content. It's a content graph, really. So you can query and tap through it and like get multiple levels of linked things one together. But when you update them, you probably don't want to do that. So to cut it short, I don't think I have good things for where GraphQL shines for mutations, except for like the expressiveness for the UI developers, mostly, I would say, working against your API. So they can be like very expressive, or you can design very expressive things for them, for like the things, put something to a card, or like add a comment to a blog post, or whatever you can come up with in there. This is where it shines, but not necessarily for very generalized kind of update strategy.
Got it. Great. And someone asked about the link for the transformer tool, and I shared the link. It's transform.
Oh, thank you very much.
I just discovered it too, and I think it's wonderful.
Yeah, it helps me so much all day. Whenever I need to do something, like, I have some data shape here and I want to get it somewhere else, I'm like, okay, let me first check if Transform Tools has it, then I don't need to do it, and otherwise I can still search on. And yeah, that's a good time saver.
Gotcha. Do you want to stay online for the second round of the quiz?
Yeah, sure. Like maybe just very quick to like this dgraph query question.
Yeah,
I think dgraph has a GraphQL-like kind of thing to query its data from the database. So I'm not aware that there is any other connectors that making it more spec compliant, but I also have not worked with dgraph in any like bigger scenario. I've literally just like set it up once and tried to play around. And I thought it would actually be supporting GraphQL and only supports a superset of it, like, the TypeScript, JavaScript kind of thing. So if you have more information around that, feel free to like reach out for more discussion. Whoever you are, anonymous, I would be curious on like what the actual problem is there.
Oh, great. We had Vignesh who just dropped a comment, and he's like, yeah, you have a dgraph GraphQL, which you can use. So I guess in this case, if you're implementing a GraphQL API that isn't the one that dgraph is exposing, you could make GraphQL calls to the dgraph.
Yes, exactly. But for that, you wouldn't need like a dgraph specific thing, actually. That's also a cool part here. You could use like anything that generates your GraphQL client in terms of like client to communicate with that GraphQL server. So you could use like the thing I just showed was like, the Prisma, for example, Prisma probably not, but like using something that just like takes the GraphQL schema from dgraph and exposes it to you, and then you put those calls into the resolvers, or you think about some kind of like schema federation, stitching, whatever. But in general, I wouldn't recommend exposing a GraphQL interface of your database directly to the customer. I would like rather shield that, and even if you do like a request or two more than you would necessarily need to do, I think it's worth it for not exposing it to the outside world.
Yeah, I absolutely agree. Great. So let's get started. Thank you again for this talk. And let's just jump into the quiz. So you should have the quiz open window. And let's get ready. So we have 35 participants so far. And now we come to the first question. So picking your own data set is a good choice when you, first, want to dip your toes into GraphQL. Second, want to try out a specific language features. And third, present something in a community talk. Okay. Let's see if we can get to 20. Okay, the results are rolling in. And let's count down to 10. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And
not quite the 20.
So most of you picked the first choice. However, that was the wrong one. And the right one was if you want to try out specific language features.
Yes. So like, if you're very new to GraphQL and like you have never really tipped your toes with it, I don't think it's good like immediately going with it. Like go with something like with those learners first. Take your data when you know how GraphQL works. Like if you don't understand how the schema language works or how the queries are written, I don't think it makes much sense to directly jump into working on that with your own data. Like get the GraphQL language straight first. That's what I mean with like tip your toes. Maybe that was also a bit misunderstanding. But yeah, once you want to try out actually the language features and its implementation, go for your own data.
So we come to the second question. What's not a good format for your data to work with? XML, SQL, or JSON? These are tricky questions. They remind me of the driver's license theory questions.
Yeah, I have to be honest, like I was doing them very, very late in the preparation phase and was like inspired by Vignesh's questions because I was struggling to come up with some. So in the end, they became maybe a bit too much of a test.
No worries. I'm glad that we have you here live with us so that you can explain. So we've got 18. I think we can stick to that. And most people picked SQL, but that was also the wrong choice. Indeed, it was XML. And I guess this was slightly confusing because... let's see.
Yeah, I can see. I mean, it's actually nice. I'm just getting feedback to my talk here by basically the question answers. The SQL part, yeah, might be confusing. I guess that was here maybe due to the naming problems that I was showcasing, but that was a fault from my side because I actually want to show that like still very much capable of working with it. And I thought that I was like showing with Hasura and Prisma quite good that there is good ways on how to use like SQL to get your data running.
All right, let's move on to the next question. The best root type to start with is first mutation, because we need to import data into the system to work with. Second is query, so we can visualize our use cases early. And third, mutation, for best live reloading style developer experience.
It should actually have been subscription down there. Did I send that wrong or was it put in wrong? I'm sorry. Like the third one would be subscription because that's the live reloading part.
So the third would be subscription for best live reloading style developer experience. Okay, let's see if we can get to 18. Give it a couple more seconds. And all right, let's close it. And most people picked query, which was the correct answer. And finally, what should be considered during the first thoughts about the schema? Authentication, HTTP server framework, or third option is collection pagination. So a quick reminder that the first prize for the quiz will be a GraphQL O'Reilly book and Prisma and Contentful swag. So let's see if we can get the last votes in. And we'll close it. Most people picked the third option, which was indeed correct, collection pagination. This is our last question for the quiz, so get ready because your speed matters, and perhaps we should show the leaderboard before. So Matthias is still leading the charge, followed by Bruce and Tobias. Okay. So Hasura, post graph file, JSON, GraphQL server, share the problem. First, they can't be customized. Second, they require specific data shape. And third, abstracting away the actual schema.
I think I've actually completely forgotten to showcase post-graph file, but that's like literally kind of the same as like a Hasura thing, just like on a more low-level thing like for your own hosting. And yeah, JSON GraphQL server, that was the name actually. I think I named it GraphQL JSON server in the talk, but I think you got it.
All right, let's close this. And the correct answer was abstracting away the actual schema. So they abstract away your schema and you sort of just get a GraphQL API.
Yeah. This one here was actually also supposed to be a bit tricky because I think they all do somehow apply, like they require a specific data shape, was like applying to one of them, but like not for the others. So yeah, that and they are also like, depending on how you treat it. So yeah, people should be still fine if they have selected it.
Okay, so we have a winner, Matthias. You will win the O'Reilly GraphQL book. Please feel free to reach out to Natalia via Twitter or to me. You got my Twitter handle just below my name. Same thing for Matthias and Bruce, who will also get some Prisma and Contentful swag. So on that note, Stephan, I'd like to thank you. We're 2 hours in, so thank you all of you for having joined today, and sorry again for the technical difficulties. I'm sure we'll get that resolved by the next meetup. And yeah, we are looking forward to seeing you again at the next GraphQL meetup. So have a good one.
Thanks for having me. See ya.
Ciao, ciao.